everything in the day one warm-up are skills that you need to be able to do in order to do the lesson. So the warm-up isn't just, it's just not random exercises for you to do. There's a reason behind it. The first is taking a whole number and changing it to an improper fraction. Do you know how to do that? So for instance, the answer, the whole number 4. What's 4 as an improper fraction? You would be right. 4 over 1. So the rule, very simply, is take whatever that number is and put it over 1. So, Owen, what would 7 be? And Eleanor, what would 6 be? Great. Now, I have a little bonus for you, even though it's not in the warm-up. What if I told you this? Hold on. What if I told you this? I want you to come up with an improper fraction. Don't write this down. Just look on the board. I want you to come up with an improper fraction that's equal to 4, but it has to have a denominator of 2. I just want to see if you're able to do that, because it does come up later in the lesson. So we might as well cover it now. Brando, how many think it's 8? Very good. What if I told you that I want you to come up with a number that's equivalent to the whole number 7? It has to have a denominator of 3. No? Oh, 21. How are you doing it? Owen, how are you doing? How are you able to come up with it? That's it. All we're really doing is taking that whole number 7 and multiplying it by whatever I give you as a denominator. With 6, what if I tell you that the denominator has to be 10? Think about that rule. Whole number times denominator will get 60. Yes. No, you'd wind up with 61 over 10 because you have to add that numerator. But for the most part, what we'll be doing is if I ask you to change a whole number into an improper fraction, keep it in its simplest form unless they specify otherwise. So keep it as anything, that number over 1. Okay? All right, so there's that skill. Yeah, Eleanor. In this case, yeah, that's the 10 rule. It works because you're multiplying both the numerator and denominator by 10 or adding a 0. Square. For which one? Over 5? Yep, 20 over 5 would work also. Okay, all good. The other skill that you need to kind of call upon is whether you remember, whether you've learned, for one, and memorized how to multiply fractions back from elementary school. You did it, right? How would you do 4 over 1, which is really 4, times 1/9? 4 over 1 times 1/9. Well, what's the rule? What are you supposed to do? Uh-oh. Did you forget? You don't need common denominators. Madison, what do you remember? That's it. Numerator times numerator, denominator times denominator. It's like the easiest thing to do. Keep it simple. So 4 times 1 is, and 1 times 9 is, my answer is 4/9. Now, sometimes you'll see you may have to reduce this. For right now, we're good. What about 6 over 1 times 4 over 1? Well, and how would you simplify that? What whole number is that, Will? Might as well make it 24. Now, when we get to C, you got to change that improper fraction, or that whole number 5, into an improper fraction first, and then multiply your top times your top and your bottom times your bottom. 5/12. And then finally, what about 9 times 5/1? Shane. You got it. 45/1. Which is what whole number, Shaney? Very nice. Done. Okay, so again, these are skills that you need to know to progress through the lesson. Let's start with example 1. And again, if you see the shortcut, we haven't done any examples yet.
Yeah.
Question. Yeah. That's what you're supposed to do. All right. All right, first word problem. How many half miles are in 6 miles? So picture 6 miles, and I'm asking how many half miles are in 6 miles. Well, what is that first as a division expression? What divided by what? Karsten. Right, 6 divided by 1/2. There's 2 ways to model it. You could certainly use the number line. The other way to do it is if you picture 6 holes. I have a fraction bar or a tape diagram, and there's 6 pieces to it, right? 1, 2, 3, 4, yeah, 6. And I divide them in half. Just put a line through it like that. That's 1 piece. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 6 divided by 1/2 is 12. The other way to do it, and I think it's the longer way around, but I'll show it to you, because sometimes the whole idea with these models, some models work better for others. Like when we were doing that fraction, like how many 3/8 or an 8 or 3/8 and 7/8, I think the number line works great. Here, not so much so, because if you want to use the number line, the first thing that you would have to do, like we've been doing, is change everything into a common denominator. So now look, I have a denominator of 2, right? If I'm going to convert that whole number into something that's usable, what denominator does it have to have? Nicole. Right. Like we did in the warm-up now, what does the top have to be equivalent to the whole number 6? What over 2 is equivalent to the whole number 6? Jen. Remember we did this? Oh, remember we did 6 times 2 makes this? Okay, this stays 1/2. Because as you remember, the reason why we're doing this is if we're going to use a number line, you got to have the same denominator. That's why this is the longer way around. It doesn't work as well. Okay, so now we have, I'm going to just rewrite it. It's technically 12 divided by 2, or 12 halves divided by 1/2. Where's my go-to? My go-to is 12 over 2. This is my leap. So now I'm still not done. Now I've got to label my lines in halves. That takes time. But we're going to do it. I'm going to show it to you. That's why I say some models work better than others. This is the longer way around. There's long, there's short, and there's super short. Super short, you'll eventually see. Okay, where's my go-to again? Jen. Make a line, that's my go-to. Leap by. No, leap by. Leap by 1/2. Look, there's 1/2, there's 1 leap. You eventually get to the same answer, don't you? 12. Alexa, I know you know the shortcut. I can see fumes coming out of your ears, but you have to wait. You have to wait. You have to wait. You have to wait. Okay, what about this? Again, it's going to get a little laborious, meaning it's going to be tedious, but I want to go through it to model it both ways, and then once we see the shortcut and once it's revealed, we can use it. All right, what if the question asks how many thirds are in 6 miles? So, first of all, what is that as a division expression? Anybody want to write it up on the board? Okay, Sebastian, go. I have red, so use a different color. Looks good. Stay up there, bud. Same thing, you have a fraction bar, 6 pieces, but you're going to divide it this time into thirds. So you need 2 lines. Close enough, it's okay. Don't worry about it. Don't worry about it. Make it as straight as you can. We got the idea. Great. All right, very good. All right, now what? Carson's got it. She's already doing it. What would you have to do next? Yeah, start numbering. And even at this point, you could start to see that, oh, I don't need to number every single one because I know each vertical column is worth 3. Yes. How many got 18? That's our answer. Think of it again. I have 6 slices of pizza. Each one I'm cutting into thirds. I'd have a total of 18 slices. All right, finish it up. There's 18 thirds in 6 miles, and then 18 again. You spoiler, you. But that's okay. That's okay, because you're going to see it. You will see it. All right, so I'm going to model it again on the number line. Let's just do it. I know. Oh, I want you to see it. I want you to see it all 3 ways. Okay? The way that Owen kind of, and then I know Alexa got it, some of you got it. We'll talk about that, because once you see it that way, I promise you that I will allow you to use that shortcut. But I've got to show it to you all the different ways so you can see why it works. Okay. And it's good practice anyway, because I want you to be able to practice taking whole numbers and forcing it into being equivalent, in this case, with a denominator of 3. So what does 6 have to become if the denominator has to be a 3? This is good skills practice anyway. Eleanor, 18 is correct. And guess what? You're going to need 18 1/3 designations. So let's just get it done. I'm going to push this on. I did this last year, and it wound up confusing kids, so I said, oh, I'm not going to do it this year. But I'm going to try it again this year. Since all of our denominators on our number line are in thirds, would you be okay with me just listing the numerators? Because honestly, once we know that all of these lines are in thirds, we don't need the thirds at the bottom anymore when we count. We really don't. But that confused kids last year, so I'm kind of hesitant for doing it this year. You see, we don't need the thirds. All we need to know is where do I need to go to and what am I leaping by. That's all we care about. So we've got to go to where? Just say it out loud. Okay, I'll put my line there. Again, I don't need that 18 thirds. I got to go to 18. That's all I care about. Leaping by how much? And here, no. That's where you got to be careful. You're leaping in 1/3. Okay? That's a common mistake. They say, oh, I'm leaping by 3 because they think 1/3, but I'm still every line is still a leap when you do it this way. And you'll see when you do this, you wind up with 18 leaps, and that's becomes your answer. Then we get to the shortcut. What if they ask you, how many fourths are in 6 miles? Is there a quick way you can find the answer without using the model? And we have about 3/4 of the class with their hands up because they know it. But I promise Alexa. So Alexa, what do you do? Whole number times the denominator. Is our answer to how many fourths in 6 miles? Is our answer 24? It works. All right. I'm going to write it down, but I'm going to expand on what she said because yes, she's right, but she's still only partially right. Hold off on. Okay. So to summarize what you said, obviously yes. The way that Alexa just outlined, even though we're gonna build on that because it's not quite right. Oh, why is there a line after that? Oh, what is the answer? Yes, 24. What is the answer? 24. Whole number times denominator. And Lex, so you're about 90% right. I'm going to give you the next 10%. I don't even know if the next page goes into it or not. Okay, you know what? It's there, but let me kind of articulate it here. So what you're really doing is this, and it's if it confuses you, then go with what she said for now. But eventually, if you kind of understand what this is really about, it will work for any fraction. And that's the best part of it, is that we're on our way to figuring out not just a whole number divided by a fraction, but this will work for any fraction divided by any fraction. Okay? So we take 6 divided by 1/4, right? What you're technically doing is, watch, I want you to make this an improper fraction over 1. Make it an improper fraction over 1. Good so far? I'm going to put it into words first, and you're going to say, wait, what? And then it'll make sense when I draw it out. Ready? Here comes the magic of all this. I shouldn't tell you this. I could tell you, but then I would have to kill you.
Yay!
Because it'll work for every fraction if you remember the rule. Where you never have to model anything anymore. Okay? And we'll eventually get to lessons where you don't have to model it at all. We still have lesson 4 where there's different types of word problems, but this will work for everything. Ready? I'm going to put it into words first, and you're going to be like, wait, what? And then you'll get it. Connie, you ready? It's like the best advice I'm going to give you all year. Dividing fractions is like multiplying by the fraction's reciprocal. Okay? Dividing by any fraction is the same as multiplying by a fraction's reciprocal. I told you, you're going to say, wait, what? Here's what it looks like. Here's what I just said. Here's what it looks like in writing. Dividing any fraction is the same as multiplying by the second fraction's reciprocal.
I did mine a little differently.
So based on what I just drew out, what do we mean by the reciprocal of a fraction? Wait, though, Nick. I'll look at it in a minute before I get to you. Let me see if we can get this idea of what a reciprocal fraction is. I know you know it. Let me go on Will. Will, what's a reciprocal mean? Sort of. Sometimes it does result in an improper fraction, but not always. You know? What do they do? What's the difference between 1/4 and 4/1? Got it. All I did was flip-flop it upside down. That's what a reciprocal is. So if I give you 1/4, its reciprocal is? What about 1/6? What if I give you 2/3? 3/2. You just turn it upside down. That's called a reciprocal. All right, Nick, I'm ready for you. Okay, so here it is in words. The shortcut allows us to divide fractions by multiplying a fraction's reciprocal. So I kind of did this on the last page, but I'll do it here too. 6 divided by 1/4 will get you the same answer as multiplying what times what? Connor. 6 times 4, but let's keep it improper. 6/1 times 4/1. Because as you'll see as we progress, not all of these numbers eventually down the road will be whole numbers. So I want you to still leave those ones in there for now. But okay? Question. Do you remember doing this back in the ratio unit? Some of you do. Because I don't know if you remember this when we were doing, coordinate plane and making equations? X divided by 3, I might be impressed if you can remember this. It's the same as multiplying what? Because some of you got it back in the ratio unit. Carson. Sort of. I got to do something. I already had the y drawn out for you. Y equals something with x, and then after that you got to figure out what to do. And I'll give you. I'll start you. X. That's the easy part. Dividing by 3 is the same as doing what? Keep going. Go. See, that's not only good. That's burgalicious. Technically, what she did was took that divide by 3, and it's the same as multiplying by the reciprocal. Now, if this is a leap for you, don't worry about it as of now. It'll make sense as we practice it. We're going to eventually get to it. Okay, so let's just go right to the shortcut. We've modeled enough. If you're going to use the shortcut, though, there is no shortcut to being able to reading a word problem, and you've got to first write it as a division expression. That's got to come first. So how many 1/6 are in 8 pizzas? So how many 1/6 in 8, which is what is a division expression? You need that first. Connor. Yes, 8 divided by 1/6. Now rewrite it using multiplication and reciprocal fractions. And if it helps you, don't touch the 8. Leave it the way it is. Just put a 1 underneath it. Doesn't matter. We good? Times. You're okay with the dot now as times? What do I do to 1/6? Snake. And then there's a typo on my smartboard, but it's correct on your sheet. It should be 8 divided by 1/6, right? Okay. So now just multiply it. What do you get? And even if you want to keep it as an improper fraction, now you can. 48/1, which is equal to 48. And it will work every single time. The key is that if you're given a word problem, you still have to figure out what the division expression is before anything. Do one more together, and then we'll break for lunch, and then at that point, you could break up into your groups and do it. So Here's an example again. You have a word problem. Let's do it together. A construction company is setting up signs on a 4-mile stretch of road. If the company places a sign every 1/8 of a mile, how many signs will it need to cover the 4-mile stretch of road? And if you get stuck, it's still okay to at least model it in your head. Oh, I got 8 miles, and 4 miles, and every 1/8 of a mile, you think of it, here's my 4 miles, and every 1/8 of a mile I got to put a sign. Oh, sign, sign, sign. So it kind of helps you to at least see it. So it's asking you, how many what in what? Ms. Gargiulo. Great. As a division expression now. Go ahead, Nick. We're good. Now we rewrite it as a multiplication. Take it. Answer. And that's how to do division in under 30 seconds. Okay? All right, we'll break, come back for lunch, and then I'll put you in groups.